channel. My name is Mr. Mesha Ngigi and welcome to eMath with Mr. Mesha Ngigi. In this video, we're going to be checking ordinary differential equations, and we checked, if you have not checked the previous two videos, we checked on two videos where when you're solving ordinary differential equations, when you get your roots to be real and different, and when they are real and the same, right? So now we're going to check the last example in that. So there are three ways in which you can solve the auxiliary part. The auxiliary part has three outcomes: when the roots are either real and equal, real and different, or when they are complex. So we're going to check the last example, and this is when your roots are what? When your roots become complex by the end of the day. So we're going to use an example and use it to solve for that. So we're going to solve, remember we always solve for general solutions and particular solutions, okay? So the question is, solve the differential equation. So the equation is given by d squared y over dx squared plus 6 dy dx, then plus what? Plus 13y equals to 0. Remember, again, we're solving for functions where this other side, there's no function, it is just a constant, okay? So we're going to solve for the particular solution, that is when x equals to 0, y equals to 3, and dy dx is given by what? Is given by 7, right? So solution. Also, remember we are still working it using what? D operator method. And together? Yes, so we're using the D operator. Let me just write it here. Using the D operator method. So first of all, you rewrite the function in terms of the D operator form. So you say just in D operator. So in the operator we shall have, so remember it is the derivative, the second derivative is represented by d squared, the first is represented by d. Yes, so this part here becomes d squared, then plus 6d, then plus 13, then you have your y outside equals to 0, right, together. So this part is this, remember, without the y. Together, it is d squared d dx squared, so there's no y. D dx. Remember, the y part is just to represent a function. Okay, so a function can have very many letters. So a y in our case here is just to represent a particular function. So that is why we are factoring out this y, and this y. It is outside here, right, together. So then we say replace m for d and solve the auxiliary equation. So you replace m for d and solve for this part. So you shall have m squared plus 6m then plus 13 equals to 0. Now that part is called the auxiliary part, this part inside there. So then you find the solution. Two numbers when you multiply to get 13 and when you add to get 6. There are no such numbers, okay? Yeah, there are no two numbers because 13 you can only get 13 by multiplying 13 times 1. No other number, and 13 and 1 cannot give you 6 at any case. So now we solve using what? We solve using the quadratic formula. So we use the quadratic formula. So quadratic formula. So using the quadratic formula, our A value there is what? It's 1. Our B value is 6. Our C value is 13. Okay. So we know, remember we are finding the value of m, so it is given by negative b, which will be negative 6, plus or minus the square root of b squared, which is 6 squared, minus 4a, 1, c, 13. Okay, remember the square root goes up to there. Then over 2a. So 2, what is your a? Your A is 1. So simplifying this, we can have negative 6 plus or minus square root of, this one is 36 minus, we have this 13 times 4, that is 50, 52, is it? Yes, 52. So 52 then over 2. This one again gives you, so we continue simplifying, plus or minus the root of 36 minus 52 gives you negative 16 over 2. Now notice something here already. You're having a negative number inside a root, okay? And anytime you're having a negative number inside a root, even when you key in this in your calculator, definitely it give you something we call math error, because especially when you're using 82ms calculator, then you cannot really get the actual value. So you split this into 2. So we will have, so again, I'll just say equals to negative 6 plus or minus. So I'll split this into 2. I'll split, so this one is negative. Just that. So this one is plus or minus square root of root 1, then square root of 16. I now split my negative 16 into 2. Negative 1 and 16, okay? Because when I multiply negative 1 times 16, it gives me negative 16 by the end of the day. Now, but you know something about complex numbers. Negative of root 1 is given by what? By j. That is when you are doing applied mathematics, yeah? But when you're using pure mathematics, then you replace it with I. But in our case, since we're doing applied mathematics, that is for the case of engineering, we use j. So we shall have negative 6 plus or minus, then this one will give us a j. Now, what is the root of 16? The root of 16 is what? Is 4, then over 2. Then you can factor out whatever is common between the numerator and the denominator, so that you can simplify it as far as we can. So 2 is common here and here, so you can have 2 outside. So what do you remain with inside? Negative 3 plus or minus. I can start with 2, then the j to follow, okay? Then over 2. So I just factored out 2. Right together. Yes, I just factored out 2. So I can now cancel. So I can cancel this and that. All right. So my final answer now becomes negative 3 plus or minus 2 what? 2j. That is the value of m. So m can have 2 values. Remember, it is a quadratic equation. So your value of m should be two values, okay? So our first value of m can be negative 3 plus 2j, or negative 3 minus 2j, right, together. So I can just put it and say, I can have m1 as negative 3 plus 2j, and I can have m2 as negative 3 minus 2j. So those are your two possible solutions that will satisfy our equation here, all right? Because we always say that our complex numbers will always occur in conjugates. So if you have negative 3 plus 2j, there must be a negative 3 minus 2j. But that's said and done. So now, how do you write this? Now the general equation. So the general equation, we can see now our values here by the end of the are what? Are complex number. So how do you write complex number? It is always given by y. The general solution is given by y exponent alpha x, then cos of beta. Let me write this correctly. Exponent of beta x plus sine beta x, where alpha is the real part and beta is the imaginary part. Okay, yes, alpha is the real part and beta is the imaginary part. So we are having, so our general equation for function therefore will be y equals to exponent. What value do you have at the real part? Negative 3. Okay, then x, then into bracket, then you have cos. What is your value at the imaginary part? Now, without considering the positive or the negative, because it can either be positive or negative, you just take the value itself. So it is what? 2. So you'll have 2x plus sine 2x. And this one is the general solution. Are we together? Yes, that is the general solution. Now, but we wanted to get the particular solution. Oh, there's supposed to be something here. Sorry, I've left some two important things. There's supposed to be a here. Let me rub this one. So there's supposed to be a here. Yes, there's supposed to be a, and here there's supposed to be b. So there's supposed to be an a here. There's supposed to be a b there. Yes, because when you're getting now the particular solution, you're supposed to get the value of a and the value of b. Remember, this one is beta, not b. Okay. Yes, this one is beta x and beta x here. So now we get our particular solution. So that is determining the value of a and the value of b. Now, so we come to the first limits when x is 0 and 3. When x is 0 and y is 3, so you can replace them in this function. So we're saying when x is 0, y is 3, so y will become, so let me just write something here. So remember, we're getting the particular. So for particular solution, we replace the limits. X equals to 0, y equals to 3, dy dx should be equals to 7. So therefore, let's put our values. So we start with this function first. So in our function there, we shall have 3 equals to exponent negative 3 multiplied by 0. And then a cosine of 2 times 0 is 0 plus b sine of 2 times 0 is also 0. Remember, where there's x, you put 0. Where there's y, you put negative 3. You put 3, not negative 3. So you have 3 equals to exponent negative 3 times 0 is exponent to power 0. And anything to power 0 is what? 1. But let me just write it. Now, cosine of 0 is 1. So 1 times a gives you a. Sine of 0 is 0. Okay, then times b just gives you 0. So you don't have to write that. So you have now, but remember, anything to power 0 is 1. So therefore, we shall have 3 equals to a. So you already have the value of what? You already have the value of a. Together. So now we need to find the value of b. Then, so from this function now you determine dy dx. So you differentiate this function dy dx. Now, if you check the function of y, it has two functions. It has an exponent function and it has trigonometric functions. So this is a function on its own multiplied by this function. Right, together. Yes, the fact that you have the exponent outside, bracketed outside the trigonometric, therefore it means it is a function on itself. Then the function on the other side is a trigonometric. So now when you're getting dy dx and you're multiplying two functions, what is your formula? V u prime plus u v prime. So you choose one variable to be u, choose another one to choose one function to be u, the other function to be v, then get whatever you need to get and replace them in the formula. So you can say we let our u to be exponent of negative 3x, then our v to be a cos 2x, plus b sine 2x. So you get u prime, that means differentiate that function. Then v prime also means differentiate the same function. So when you're differentiating exponential function, you drop the power. So you shall have negative 3 exponent negative 3x. Remember, the value of exponent does not change. You're only dropping the power. So we have that. Then we have trigonometric. When you differentiate cos, you get negative sine. When you differentiate sine, you get cos. But you remove the constant. So here you shall have negative 2. You remove the 2, but you have an a here. Okay. Then cos of 2x plus, remove the 2 again. So 2 to be 2b. Then this one becomes, remember this one changes, sorry. This one changes to become sine. So this one becomes sine 2x. This one becomes cos 2x. Okay. All right. Allow me to rub here for now. Okay, so you have your first derivatives with respect to for the function of u and the function of v. Now replace them in the formula. So we know that our dy dx will be given by vu prime. What is our v? This one is our v. What is our u prime? This one is our u prime. So we can have the exponent outside. You can just start with u. There's no difference. Exponent of 3x, then a cos 2x plus b sine 2x. Okay, now my space is limited. Let me write it here. Just a minute. Grab this kindly. Grab this. Increase the space. So we have dy dx will be given by uv prime, vu prime, sorry. So you take your v, you take these, you multiply by this and this. So I'll start with an exponent outside. So again, I'm saying it will have negative 3 exponent, negative 3x into bracket, then a cos of 2x plus b sine of 2x, okay? Then plus, what do I add? U v prime. So u is our u is our u here, which is exponent negative 3x, then v prime is this, so negative 2a sine of 2x plus 2b cos of 2x all together. Yes, now that is your function. So you really don't need to open the bracket. What you need to do now at this point is to now replace your values, your limits. And which limits will you use? Dy dx and x. Okay. So what is your dy dx? 7. What is your x? 0. So you shall have 7 here equals to, so x is 0. So we shall have negative 3 exponent. This time 0 is just 0. Then a cos of 0 plus b sine of 0. Then plus exponent power 0, negative 2a sine 0. Okay, yes, because it is 2x times x times 0 times 2, which is just 0. Then plus 2b, then you have cosine of 0. Okay, then you now evaluate everything. We know anything to power 0 is 1. So outside here, you just remain with negative 3. Cosine of 0 is what? Cosine of 0 is also 1. So 1 times a gives you a. Sine of 0 is what? Sine of 0 is 0. Then times b just becomes that. So you have that. Then plus. Exponent to power 0 is 1. So I don't need to write anything there. Then sine of 0 is also 0. So this one is 1. Okay, let me just have it. This one is 0. Then cos of 0 is 1. So 1 times 2b, get 2b. All together. Then you open the bracket. So equals to negative 3a plus 2b. But did we have the value of a? Yes, we got the value of a, which was 3. So 7 equals to negative 3 multiplied by 3 plus 2b. So 3 equals to negative 9 plus 2b. So negative 9, you take it to the other side, it gives you what? And you add, it gives you 16 equals to 2. B divided by 2 divided by 2. So your b equals to what? Your b gives you 8. And now from that point, you can now have your general. No, now this one is particular. So your particular solution. So just come and have this function and now replace the value of a and the value of b. So it will just be y equals to exponent negative 3x into bracket. What was our a? Our a was 3. So 3 cos 2x. What is our b? 8. 8 sine 2x. And that gives you your particular solution. So anytime you're calculating a particular solution, that is just the outcome by the end of the day, because you are, and this one is when you're having complex. When you're having complex, you write a general equation, and the general equation you differentiate it, you get dy dx, then input your limits and just evaluate the value of a and the value of b. That is the reason you're always given the three conditions: when x is 0, y, and also dy dx. And that is it for what we call ODE. Okay, that is when your function on this side is what? The function on this side is 0. Like you don't have a function, you don't have a trigonometric, an exponential, and so on and so forth. Now, in our next lesson, we're going to be checking how to now work functions that have to work ordinary differential equations where there are functions on the left-hand side or the right-hand side. Yes, when you're having functions on the other side of the equation. Right. So thank you so much. If you've not subscribed to my channel, subscribe, share, and also comment and let me know how I can be of help time and time again. Thank you and see you in the next lesson.